Okay, let's start the class. Today we are going to move on to the exam 3. So here is something we want to mention. Exam 1, exam 2, exam 3, and we had a so-called final exam. I usually call it exam 4. Okay, that's each is worth 100 points, 100 points, 100 points, and 100 points. There's a couple of extra points there, so we don't talk about that too much, although it's all counted. So in order to help you to survive or you do well, whatever you call it, we will be offering a bunch of extra points right here, besides the normal extra points. So here is the thing. What we're going to offer: glide, color, cis, cycle, chemical, plus structure. No enzyme. Okay, I don't care about the enzyme. I'm talking about microorganism. I don't teach biochemistry. So although we talk about biochemistry, there will be 1 point of each thing. So here we example. Glucose. Okay, glucose. Okay, like that, for example. Just give you 1 point. Okay? Just give you an example. One example. One chemical and one structure will be 1 point. Second, citric acid cycle. Same thing. Chemical, structure will be 1 point of each. Number 3, all side chain of amino acids, 1 point. This is easy. That is 1 point. Okay? So CH3, alanine, even AL is fine. GLY is fine. That's another 1 point. Is that right? Is that so simple? So that's some extra points for you. So the idea is, we are talking about is move on to biochemistry and the genetics part of the microorganism. Majority of them are very similar to what you learn in the other classes. But the difference is that we're going to focus on the bacteria. In the other classes, is focused on eukaryotes. So a little bit of difference, but I would say 99% of the content are the same. But I presented the way is maybe different from the others. Okay, so that is what we're going to do. You can calculate there are lots of points in. Maybe like at least 40-ish, 30-ish. This final exam, we also going to offer you is an essay writing. So what's the essay writing will be 30 points, 250 words, which is in the classroom, you have to write, handwriting, not computer printed. The topic will be sexual activity, transmitted disease, or STDs. It is a social problem versus medical problem. The topic will be like this. The detail I will put on the e-campus by the close to the end of the semester. That's 30 points. This is almost at least 40 points right here, plus some normal ones. So you get about literally 80, 90 points there. Still can be using like an insurance. Okay, so I hope you do it. That's we help you. Because we separate the lab and the lecture, there's not many space. You can really to help too much. So that's what we will offer you to do. Okay, so we're trying to help you to do a good one, but you have to study a little bit. Another thing why I wanted to do this, because wherever you go, you learn all the classes, the biochemistry and the genetics is basic knowledge you're going to learn all the time. Since you're high school, from biology 101, go advanced nutrition, go general microbiology, go biochemistry, whatever the advanced molecular microbiology, whatever you call it. Those basic things you're going to go again and again. So I hope you use this time to just study hard and earn the points. And once you said, have a good memory storage in your brain, then you go all to school. In the future, it's all easy. So that's why I want you to do that. And you put some efforts there, we give you some credits. So that's the idea. Okay? So next, we want to also going to tell you what we're going to talk about exam 3. Exam 3, I just mentioned, basically is biochemistry and basic genetics. So what we're going to talk about that? The biochemistry class today will be an introduction. We basically going to focus on is how bacteria get ATPs. So the ATP calculation will be the key, and everything will be focused on the energy currency, how bacteria get the energy. So we talk about the fermentation, we talk about the glycolysis, TCA cycle, and very briefly mention pentose phosphates. Then genetics part, we basically talk about is the central dogma. And we're going to focus on the central dogma. We will mention the DNA, replication, DNA, transcription to RNA, and RNA, due to translation, become protein. And we also will mention the detail of post-translation operation, which is we talk about lacto operation. So that will be basically the key of the class. These you learned already in other classes, but we will be a little bit different. Most of you folks who UK youths, we are talking about the bacteria, especially the translation here, transcription, a little bit different. Okay? So that's pretty much the outline what we're going to talk in the exam 3. So the topic today we will talk about is introduction of metabolism. So today we basically talk about introduction. Here is another thing I want to mention. In here, I basically going to draw millions of things on the blackboard. The idea for learning is you look at the notes and then go back to study the slides, but don't use these slides as each individual piece of paper. If you have all these pieces of knowledge on your mind, it's very difficult to remember, very difficult to learn. There are all these things could connected together. So I will usually say these 5 slides are all the same, are all the same topic. We should talk about all these together. And that's the way you can learn. It's easy. Okay. First of all, what is mechanism? Metabolism. Sorry. Metabolism basically has 2 parts, which is catabolism and anabolism. In here, the major difference is catabolism is large molecules break down, become small molecules. At the same time, we generate energy. And anabolism is small molecular using the energy generated from catabolism, and the biothings become a large or macromolecular. And you always remember these 2 things are coupled in a bacterial cell. They have to be doing this all the time in their lifetime. If they stopped in any of the steps, the bacteria will be died. And here, because of the time limitation, we will be only talk about catabolism. We won't mention about anabolism. There is another class we'll mention anabolism, which is microbiology physiology. If you study microbiology major in some of the university, but we don't talk about that. Why? First of all, you learn in other classes. Second, the bacteria for us is too small. Their lifetime is too short. Lots of the bacteria is 16, 24 hours. If we spending too much energy here, talk about anabolism, some seems like it's wasting time. So from our standpoint, we will focus on catabolism. Okay, so here is a definition. You can read again on the slides. Degradation, breakdown of complex molecules to simpler molecules and yield energy. We'll talk about exogonic. Anabolism, biosynthesis, complex molecules from simple compounds. Endogonic reaction, energy consuming. But the energy where they comes from the catabolism. They are coupled. This is another slide which tells you the connected between that. You can see some of the chemicals called precursor chemicals. They generated during, for example, from TCA cycle, from glycolysis cycle. And they were using as a bridge to carry on the energy from catabolism to anabolism. So basically, is you invested and you're going to build up something. Think about this way, like you invest a house and you buy the bricks by the labor cost, and then the house finally going to be built. So that's the same thing for all the cells in the bacterial structure. So these are basic knowledge. We already know about that, but keep in mind the metabolism is catabolism and anabolism, they combined together. Next, we want to talk about is a thermodynamic law. I'll be just right here because these are thermodynamic law. You heard about these already. There are basically two laws about. Number one, if we said very simple, is energy never create or disappear. They only is transfer. And specifically in a bacterial cell, we talk about is potential energy going through kinetic energy. The kinetic energy, we'll mention about that. The bacteria could use it. This is a concept which is a physics concept. So we will give you a very simple example. Not sure you know about that. You learn the physics, talk about this puzzle. I have a ball right here. Okay, I have a track right here. Okay, this is the height, is h. Okay, when the ball is there, there's a potential energy. And then they're going to fall off. When this guy falls off, they're going to pale, the track going to move it. So, based on this principle, the energy will never disappear, and the created will only be transferring, and ideally, the energy will be the balance, will be the same. So, we have this formula comes out. If you learn about that. Okay, now at this moment, this M, we can delete it. Assuming, of course, this is going to be M1, M2. Assuming the ball and the track are the same, then we're going to just delete it. So at the end of the day, what's going to happen, the velocity and the speed of the truck is basically how tall and how height is the ball. Because the ball has a potential energy. And then at the end of the day, the truck is moving, which is the kinetic energy. So that's a very easy example to explain about what is a potential energy transfer to a kinetic energy. Okay, so a little bit of physics behind this. And in the bacterial cell, that happens all the time, is the same thing. Now, the law number two, it could be very complicated. It could be talk about all these formulas or some equations. If you say it very simple, is disorder increase? When the body of the bacterial cell are alive, during their life cycle, they have to combat all the stress environments. In living a poor nutrition conditions, they have to survive. At the end of the day, their disorder is increased. Then they have to do adjustments. If they cannot do the adjustments, then they will be died. It's so simple. They cannot be survived and they're too stressed. When they reach the threshold, they will be died. So the second law is so easily understand is disorder increase Then they give you a terminology called entropy, which is entropy is increased. Okay, so that is very simple. We mentioned about first and the second law of the thermodynamics. We're not going to get to detail of these because this is a physics concept. So we just want to be briefly mentioned about here. Now we want to talk about a detail of this ATP, and all of these slides should be combined to think about that. Then we move to talk about the other topic. So we move this out, and we want to focus on talk about ATP, the energy currency. So first of all, what is ATP? Everybody knows it is an energy currency. It is called ATP. Now, what is the structure? Every time when we learn these things, I hope you draw a structure, at least on your paper or in your mind. We're going to talk about it, then you can understand it very well. First of all, there is a 5-carbon sugar right here. Basically, it's a ribose. This is a 5-carbon sugar. As a 5-carbon sugar, we have another name for it. It's called a pentose. This is a reason why we have a pentose phosphate pathway, which is generate a precursor chemical to generate all these type of genetic base. That is what A comes out. So first of all, there's a ribose. Now, what is the structure of a ribose? H, CH2. And then you go here, you have H. So what is the carbon? Carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. That's a ribose. Now you know that if this O is gone, that is DNA, deoxyribose. So that's why we say 2' deoxynucleotides. So we have a O, it's a ribose. Okay, on this side, we're going to add something there. Okay, what we're going to add? This is going to be a little bit complicated. So we go here, and then we connect it. Okay, then we have this guy, this guy, this guy. And here, N, NH2. We have N right here. Okay, you can do right here and right here. And what is the number? Is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, what is that? This is a gene base. Adenine. Is that right? That's a ribose. Then the major part here of this phosphates is connected right here. So you have O, you go here P, OH. Then you go O, you go P, go up, hydroxy bonds, OH. Then you go O, go P, OH. So there's 3 O there. And always remember, this bond is not very stable. They storage a high energy, so we call it a high energy bonds. Therefore, this comes out with a 4 name right here. What is that? This prime is 5 prime. 5 prime, adenosine, 5 prime, adenosine, triphosphate. This 5 prime, which means right here, and where this ATP comes from, this means A, this means T, and then that means P. When they add them together, we have ATP comes out. And we all know that if it goes here, only here we will say monophosphates. That is AMP. When you go here a little bit longer, this is called diphosphates. That is ADP. And finally, this is ATP. And we also know that ATP could be hydrolyzed, become ADP and PI. Okay. Now, of course, ADP could be further become AMP and PI. And don't forget, I said it all the time, this AMP could also become CAMP, which is based on the enzyme is cyclase. When this happens, usually disease will be accompanied by it, because like loxamine, which is cyclic. So it don't let you to further process become ATP. Okay, so that's basic principles here, talk about the ATP. Now here is the thing which comes out. When we have this ATP generate, how we will generate ATP really? This is basically is here related to these very unstable high energy bonds. Because of these unstable high energy bonds, so the phosphate could be released. So how do we know when it's going to release, when it's not going to release? So it comes out with a formula called delta G equals delta H and then minus T and delta S. This formula looks like it's very abstracted. I will say it's not very easy to understand it. So basically this is a free energy. Free energy change. And this is, we call it entropy. Is that right? If you see the details of right here. This is, we call it entropy. And this guy, delta S, is entropy. And then we have a T. And this T is also very tricky. This is an international unit of a temperature. It's Kelvin. Kelvin. That equals 273 degrees Celsius. So this number is not really a degree Celsius, not a degree Fahrenheit, it's Kelvin. Now, here the first formula comes out. It looks like not very easy to understand it. But there is a basic rule behind this. If delta G is less than 0, which means it's negative, which means the reaction could be happened immediately or spontaneously. So there is a spontaneous reaction happen. Once the delta G is larger than 0, we say it's a positive, then there is no spontaneous reaction will happen. So that's a major difference. Then this formula looks like it's complicated. That's so complicated formula, it's very abstract, how you really understand it very well. We had a basic formula comes out, which is delta G0 prime. That equals minus 2.303 all T and log KEQ. Here we want to measure what is R. This is the heat constant. T is temperature, this is we know. Now, this guy, I don't know you heard about. Do you know the formula PV equals nRT? This is a very simple formula, can explain why in a cold weather, or suddenly the temperature drop, your tire become flat, and you have to fill the air. Because when the temperature is go down, this P is go down. So the tire pressure will less than 32 psi. Then you have to fill the air into the tire. Remember, you go like Giant Eagle, they give you free air. Some places charge you $1.25. That's what it is. That's what R comes from. This is a fixed number, is a heat constant. And here is the same thing. Okay, so this is to help you to understanding what this means. Now, we end up with this Kg, with this KEQ, what this means. So we have a chemical, let's say A and B. They will be reactive. then we'll generate C and D. Okay, what is going to be the KEQ means? That's called equilibrium constant. The equilibrium constant, which means the factor, the index which to evaluate the balance of the biochemical reaction. Now, of course, most of the reaction is reduction oxidative reaction in the biology standpoint. So how you calculate this one? There will the concentration of the product C and D, say, multiple and divided by A and B, which is a substrate. So basically here is the substrate. And right here is the products. So you come out with the KEQ. So here will be the thing. This here you need to know. Log 10 KEQ. If this EQ is 2, what's the value? Is 0.3. Because 10, 0.3 equals 2. But remember, 10, 0 is equals 1. So the idea is, if this KEQ equals 2, this number is positive. Is that right? Because we have a negative at here. So what is delta G will happen? So delta G, 0, will be less than 0, which means it's negative. But how about if the KEQ is less than 1 but more than 0? Let's say this KEQ equals 0.1. Then what is log 10 comes out? What is log 10 KEQ mean? So results. And that will be equals minus 1. So you have a minus 1 right here, and then you have a minus here. The minus and the minus, when they multiply together, become positive. Therefore, this delta G0 will be more than 0. It's a positive. And we already mentioned that we really would love this delta G is negative. Because when the delta G is negative, there spontaneously reaction will be happening. And we already calculated, the scientific area already calculated. Regarding the phosphate's energy transfer right here, there is a value could be used to evaluate the chemical transferring phosphates. Because the phosphates is important, they will generate energy currency. Therefore, we have several numbers for that. So, ATP, if they becomes ADP and release a PI, what their delta G is? Their delta G is kind of equals minus 46. And which means their phosphate transfer power is 46. At this moment, this minus will be taken out. I'll just use a number, just use 46 as an example. Okay? So that means ATP itself has a really strong, relatively, we'll say, relatively strong phosphoryl transfer power or potential. Remember, we talk about potential energy, we say potential. And whatever we say phosphor transfer, you can just write a P there. That's the phosphate transfer potential. Now, there is something happened. Because it is have a very strong phosphate transfer, so they could transfer it. However, it is not the strongest for all the chemicals. There are lots of the chemicals generate during the anabolism process or catabolism process. Basically, the catabolism process, their energy phosphate transfer power is higher than ATP. So for example, I gave you an example. Phosphoenolpyruvate. And their delta G is basically, if you look at the table, how high it is, there will be almost 61.9. So that is minus 61.9. So that is 60.9. And there is another chemical, which is 1,3-phosphoglycerate. That is about, if you look at here, that number is about 49.3. And that delta G is minus 49.3, and it's 49.3 phosphate transfer power. Both of these numbers are more than 46. So what happened? They basically could do is A and B generate C and D, could let this reaction go the opposite direction. So the ADP will generate and it becomes ATP. And these type of the process we call substrate level phosphorylation. Now, then you're gonna ask me, where these things come from? This, you need a basic knowledge right here. This we will talk about next week, but we want to be just briefly mention about here. More or less, you heard about the glycolysis. So what is that? If we draw glucose become glucose 6-phosphates become fructose 6-phosphates, then become 1,6 by fructose phosphates, and then we go here, which is 3-glyceroldehyde. Then we go here 1,3 by phosphoglycerate. Then we go here 2,3-phosphoglycerate, and then go 2-phosphoglycerate, and then go up phosphoenolpyruvate, and finally we generate products which is pyruvate. And of course, you know, right here, start from here, this is a branch, is that right? So where is this chemical? Phosphoenolpyruvate is right here. And where is the chemical with 1,3-biphosphoglycerate? It's right here. And these, if you look at the glycolysis, they are coupled with ADP with phosphates, so they generate ATP. And here we also have ADP with phosphates generate ATP. And this is called substrate level phosphorylation, because these chemicals, their phosphotransfer power, the delta G value is more negative than the delta G value of ATP itself. So that's why it's easier to transfer. And which, in other words, their phosphate transfer power is higher or greater than ATP itself. But then there is a question. How come right here? How come these guys? How come right here? Why these? They do not have an ATP generation. And you can look at the table here. Glucose 6-phosphates and the glucose 1-phosphates, their delta G is more positive then ATP itself, you look at here, and you look at the ATP itself, right here, and then the phosphate transfer power is much smaller than the ATP itself. So these type of chemicals, they cannot be involved for the substrate level phosphorylation. Okay, so said very simple, what is substrate level phosphorylation? Chemicals has greater phosphate transfer power than ATP itself. So they could be trigger the reaction. What's the reaction it's called? Exogonic. Exogenic. How about this one? Endogenic. Endogonic. That's what's the difference here. Okay, so overall here, all these slides tells you is if you combine all these together, what this tells you, we really care is this delta G is free energy. This free energy has to be negative. It cannot be positive, because if it's positive, unless you have other external force to make it negative, otherwise the reaction will not be happen. So we need to make sure it is negative. Then we have this overall concept, entropy, enthalpy. We don't have to worry about these too much because it's a physical standpoint. We only the key here is we would love this delta G should be negative, because once it's negative, the spontaneous reaction will happen. If it's positive, there's no spontaneous reaction. Then how are we going to get it? There is a standard formula there. The standard formula in your slides is right here. There is a standard formula, which is minus 2.303 RT log KEQ. What is that? What is KEQ? The key thing is the equilibrium constant, which means a biochemical reaction, at the end of the day, they'll reach the balance. And that will be the product's concentration divided by the substrate concentration. That's equilibrium constant. And we hope this KEQ has to be positive. Not only positive, it has to be more than 1. Because based on this log 10 calculation, when it's more than 1, this value is positive. And here you have a negative, so delta G will be negative. That means spontaneous reaction will happen. That's what we call the exogonic reaction. And how about if this is more than 0 but less than 1, this end up will be minus. Minus and the minus will become positive, and then that's endogonic reaction, which means the reaction will not naturally happen. Based on this concept, then we apply this concept to ATP itself. And then lots of the research has been done. They find the delta G of ATP hydrolyzed become ADP and the phosphates is minus 46. And the transfer to, very easy transfer to the phosphate transfer power is 46. Then we're going to see some chemicals in the bacterial life cycle they generate have a higher phosphate transfer power. Let's say phosphoenolpyruvate. Let's say 1,3-biphosphoglycerate. So therefore, they could trigger the reaction, go to the opposite direction, which is ADP and the PI generated with ATP. And this is called substrate level phosphorylation. Now, although in our life cycle we generate other chemicals, seems like they carry on phosphates, but these phosphates will not trigger ATP generated. The reason that ATP transfer power is less than ATP itself, so the reaction cannot go the opposite way. So that is fully understand what the story behind the substrate level phosphorylation. Now, there's another way to explain. I don't like it, but lots of people will say, because occidental phosphorylation is involved in electron transport chain, and the substrate level phosphorylation without electron transport chain. I don't like that concept. Some people mentioned. This is something I like. To make a joke, I said, if I have a question, ask why you are a boy, and you answer, tell me because you are not a girl. That doesn't mean anything, is that right? That doesn't tell you about the story behind it. But here, these slides, I really like which is well explained what is behind the story of substrate level phosphorylation. Okay, so that's what we want to talk about that. So since we mentioned about the oxidation reduction reaction, and since we mentioned about the electron transport chain, so the next thing what we want to talk about is those two concepts. Okay, so we're going to remove these. And I would love to just take a picture right here, and I will be put this on the eCampus during the review section. If you guys, some of you haven't taken a notes, then you can well understand about it. But of course, we have slides about it. So next one we want to talk about is oxidation and reduction reaction. And these things you should already learn in the biochemistry class or basic general chemistry class, but we want to mention here also. First of all, what is oxidation? What is reduction? Oxidation is lose electron. Basically, you lose energy. Lost energy. So, what is the example? Think about 80 years old grandma's face. Lose energy. What is a reduction? Now, of course, gain energy. Gain electron. Gain energy. So what is that? 18-year-old girl's face is reduction. More energy. Is that right? That's a very easy, simple thinking about the example. I'm not discriminating other people. I'm just giving you an example from a biochemistry standpoint. Now, you still didn't remember very well. Then I have a little bit tricks for you to understand it. Do you know there's an exam called GRE? I don't know whether you know this or not. Since COVID-19, all these exams is taken out. Graduate recording exam, if you go to a graduate school, WVU is not required. If you go Harvard, they're required to take that. Is that right? GRE exam. Gain, electron, and reduction. Okay? Is that so simple? Then oxidation is lose. Then you just go the opposite direction. Is that right? Twist your mind a little bit. So that's, remember the GRE, you know. Gain, electron is reduction. So that's the simplest way to remember. Then we want to have another basic knowledge to ask you. If I have a compound B, compound A, so generate compound C and D. Okay. What happened is this guy is lost electron. Now, of course, electron going to transfer. So this guy will be an electron. Can you tell me what is oxidized products? What is reduced product? What is oxidizing reagent? And what is reducing reagent? Ask yourself. It's a very basic knowledge. We will mention this again when we talk about fermentation. What is oxidized product? A is lose electron, become C. Is that C? Oxidized product. Since this is lose electron, so what is that? Where it comes from? This electron transfer to B. So reducing agent is A. So what is reduced product? Is D. What is oxidizing reagent? You only have one left, so B. Is that basic chemistry? So you should know about this, and we will mention this again next week when we talk about fermentation. Okay? That will be a kind of exam questions always will ask you. And how you remember it, start from here. When you see loose electron, this is oxidized products. Then this is reduced products. So you can say OP right here, just here, OP. Then the other you figured out, okay? Reducing agent and oxidizing agent, because this is transfer electron goes through. Okay, so that's a basic stuff. Next couple of slides, we want to mention is the electron transport chain and also related to oxidative phosphorylation. So we would love to have all these slides we combine together. We want to talk about it. This is the key, another topic besides the ATP. We want to mention the detail that you can understand well. I draw the picture already in the lab section where we talk about oxidase test. And you're going to test it real quick so we can review the sum of the knowledge based on our practice. Okay, this is what I want to start. Electron transport chain, ETC. You need to know what is the standard electron transport chain looks like. Of course, some bacteria are different. Environmental bacteria, oxidative reducing bacteria, some sulfur bacteria is different. But the standard bacterial electron transport chain, you should know, it all comes from NAD, go to FAD, then go to FFM, FES compound, go to coenzyme Q, COQ, then go to cytochroma C, cytochroma A, and go to cytochroma A3, and finally is oxygen. And the electron is always transferred like this. Which means they also carry on the energy. You always remember, when the electron transfers, they carry on the energy. Okay, this is the standard electron transport chain. We are going to briefly mention these.